All right, in this video, we're going to introduce factoring techniques, and we're going to look at finding the greatest common factor of a quadratic expression. So the greatest common factor, or GCF, of an expression is the largest term that divides into each term of that expression. So in prior math courses, you may have talked about the greatest common divisor for two numbers. For instance, the greatest common divisor of 4 and 10 is 2, because 2 is the largest number that divides into 4 and also that divides into 10. And you'll need that for this as well, but we're also going to look at using algebraic terms in addition. So to find the greatest common factor of an expression, of an algebraic expression, first find the greatest common factor or greatest common denominator of the coefficients. So for instance, if your coefficients are 4 and 10, your greatest common factor of the coefficients is 2. So greatest common factor, same thing as greatest common divisor. Then, as far as your variables go, for each unique variable, so if you have more than one variable, let's say you have an x and a y, select the lowest power of each of those unique variables. For instance, if we have x squared and x cubed, the greatest common factor is x squared, and to see why that is, use actual numbers. So if we look at, let's say 2 squared is 4 and 2 cubed is 8, 4 will go into 8, but 8 will not go into 4. So we take the lower power, 2 to the second power versus 2 to the third power, as the greatest common factor for variables. So then you just divide each term by that greatest common factor. All right, example 1, factor the greatest common factor from each. So we have 16x to the 5th plus 72x cubed minus 36x squared. So let's look at our greatest common factor of our coefficients for 16, 72, and 36. The greatest common factor, or greatest common divisor, is 4. Now for our powers of x, our lowest power of x is 2, so the greatest common factor for the variables is x squared. So we're going to put these two greatest common factors together. Our greatest common factor is 4x squared. So if we want to write that in its factored form, we just write the 4x squared, and then we just divide each one of these terms by 4x squared. So for instance, 16x to the 5th, when we divide it by 4x squared, 16 divided by 4 gives us 4, and then x to the 5th divided by x squared, we subtract our exponents, we get x cubed. So, and we can check that by multiplying 4x squared times 4x cubed. We do get 16x to the 5th. Next up, 72x cubed divided by 4x squared. 72 divided by 4 is 18. And x cubed divided by x squared is x to the first, or just x. Finally, negative 36x squared, when we divide that by 4x squared, negative 36 divided by 4 is negative 9. And then x squared divided by x squared is 1, or x to the 0 power. So our factored form of this expression is 4x squared times 4x cubed plus 18x minus 9. Part B, we have 5a to the 4th plus 70a squared minus 25a. Looking at our coefficients of 5, 70, and 25, the largest number that divides in each of those is 5. So now turning our attention to the variables, our lowest power for our variable is 1. So a to the first power is our greatest common factor for the variables. And again, we don't really typically write the 1 there, but I wouldn't mark it wrong if you did. So our greatest common factor is the term 5a, or 5a to the first. So now we just divide each of these terms by 5a. 5a to the 4th divided by 5a is 1, and then a to the 3rd, so, or just a to the 3rd. 70a squared divided by 5a, 70 divided by 5 is 14, a squared divided by a is a. And then negative 25a divided by 5a, negative 25 divided by 5 is negative 5, and a divided by a is just 1, so, or a to the 0. So our factored answer for example 1b is 5a times a cubed plus 14a minus 5. All right, so that about does it for this video. Thanks for watching. I'll see you next time.